afternoon, Mr. Anurag. Thank you for being here with us. I'll start asking some questions now. Please tell us about yourself and a little bit about what you do.
My name is Anurag, like you know already, and I live in Dehradun, and I have been here for the past 12, 13 years. Before I came here, I was living in US. I was there for about 14 years. I'm a software developer. I'm a software engineer. I passed out of IIT in 1993 and joined IBM, and then moved on to US. And I was there in US for the longest time. I changed a few jobs. I joined Nokia, and I was with Nokia for about 7 years, and then I joined Microsoft in Redmond. So in 2007, 2008, mostly for personal reasons. My parents were here, and I had a desire to want to be back and be with them. And in Dehradun, I started teaching in an engineering college here close by. I was teaching computer science students programming, and it is around this time that I got interested in AI and machine learning and those kind of topics. And ever since then, I have been in some form or the other connected with this topic. And in 2015, I tried a stint with Big Basket, which is an e-commerce company, and I was leading their data science department. Um, After that, I moved on and I joined a friend to work on a AI problem. We were thinking of using AI to help diagnose diabetic retinopathy, which is a disease of the eye. It happens to people who have diabetes. And so we worked in that area for a long time. Eventually, I joined Nagarro in 2017, and I have been there since. So, very briefly, that's the career path you asked about me, but I thought that's just pretty much, it'd be a good summary of who I am at some level. Hopefully, that helps.
Yeah, that was really interesting. And my next question is, what is AI? I know we all hear about it a lot, but I don't think we really understand what it is at deeper level. I think when we think about AI, our mind immediately goes towards robots. So could you please elaborate a bit about that?
You're absolutely right. There's a very good reason why our mind goes automatically to robots, and it's not now. It's not now that people have been thinking of AI or have been thinking of AI in this manner. I don't know if you're familiar with the story of Pygmalion. It's a Greek story. There is a sculptor. He ended up he made a small statue of a woman. He named her Galatea, I think. I'm not sure, but something like that. It's a Greek story, long, long time ago. I think the story was written by G.B. Shaw sometime in the late 1800s or early 1900s. I'm a little vague on those details, but around that time. And the idea was that this sculptor, he liked the statue so much, he wanted to make it come alive. And the idea is very similar. We want to be able to create things which look like us, act like us, behave like us, and have consciousness at some level, right? And so pretty much all science fiction has started with this idea, the idea of robots, which are made in the form of a human being, and that's why we have this thing about AI and robots, so to speak, right? Um, so that's the general idea. So you're absolutely right. It's not a wrong idea. It's actually a reasonable idea because that's how human beings think. But of course, you're right. AI is much bigger than that, right? So in a very simple way, the idea of AI is to be able to make machines which have the same abilities to understand, to think, to act like human beings, right? In other words, that they are conscious. That's the idea of AI, right? That's what is called artificially intelligent. Right now, whether we can succeed in this area, in this goal or not, is another thing. But the whole point of AI is to be able to think of man creating machines in their own form, in their own shadows, just like human beings, right? But of course, the field of AI is very big. There are many things that happen in this field. The earliest AI was all about what is called expert systems. So people thought that, hey, listen, if we can take all the knowledge that a doctor has and represent it somehow in a computer, then next time when some patient wants to talk to a doctor, they can tap into that knowledge of an expert system. So back in the early days, and when I mean early days, it means 1980s, 1990s, these expert systems were very popular. At least people used to think a lot about expert systems. But it was not really AI, it was just a collection of knowledge represented in a very intelligent way in a computer system. Today, AI has become a much bigger topic. There are many other things that are going on. One of the simplest things that we associate AI with is the ability to be able to see things and recognize things, right? Human beings do this very naturally. So machine vision is an area in AI where we try and teach machines how to see and understand what they see. Similarly, there is an area called natural languages processing. Natural languages processing is an area where human beings, just like we can understand each other, talk with each other, we want machines to be able to do the same thing. So we want machines to be able to understand us, to talk back to us, to be able to reflect our emotions, and so on. So that area is called natural languages processing. There's, of course, robotics. Robotics is all about having machines which will move and lift and do things just like we do, and maybe even like in a much better way. So there are many things that are going on. One of the most popular topics, or one of not popular so much, but one of the most fast gaining topics in AI, which is something that I do, is the area of called machine learning. And machine learning is one of the most important areas of AI that have become very popular, and they have the most promise. At least that's what we can see today. So today, when you talk to somebody and they say that they work in AI, unless they are a neuroscientist or a cognitive linguist or something like that, most likely they are a person or somebody who works in the area of machine learning. And machine learning is one of the topics in artificial intelligence, which is the most prevalent topic that most people are working on. So what do we mean by AI? So by AI, we mean generally all of that I talked about. But then today, what are we doing when we do and work with AI? Then we are doing a lot of machine learning and deep learning. Those are the two topics that are the most natural areas that we think of when we think of AI. I don't know if that cleared up or did I confuse you more?
No, no, it cleared everything up. And well, my next question was actually, which I think you've actually talked quite a bit about, was what the difference between AI, machine learning, and data science was.
So you asked me what is the difference between AI, machine learning, and data science, and let me try and make it um, um, answer that. So AI, like I said, is the general area which has many, where the general goal is to try and make a machine which it acts, thinks, and behaves like a human being, right? So that's the area of AI. Anything that you want to, any technology that you want to use to be able to do something like that is basically AI at some level, right? So if my goal is to make a machine that can think or act or feel or behave like I do, I might be using neuroscience, I might be using cognitive psychology, I might, whatever, different, I might be using computational science. There are many tools to be able to that people are using to be able to make AI happen, right? So some are psychologists, some are brain scientists or neuroscientists, some people are computer scientists. There are many different fields which are trying to make AI happen. So AI is a vast area where the goal is to make some machine which is capable to do pretty much everything that we can do, right? So that's the area of AI. So there are many technologies. Machine learning is the idea that you can take some information, some data points, and teach an algorithm the relationship between the inputs and the outputs. So, that this idea that you can take an algorithm and teach it something very specific is the idea of machine learning. So let me give that, illustrate that with an example. Let's say I have some dog pictures and I have some cat pictures. So how do I use machine learning to teach an algorithm like this? So what I do is that I'll write an algorithm, and there is some some specific algorithms that I write, and let's not talk about what type of an algorithm it might be, but just imagine that there is a black box where there is some algorithm written, right? So what I'd show is that I'll show it one dog picture and give it the answer that this is a dog. So the machine now has one dog picture and the answer that this is a dog. Then I show it a cat picture and I give it the answer that this is a cat. So I keep doing this. I show it hundreds of dog images, and each time I show it a dog image, I say it's a dog. Each time I show a cat image, I show it as a cat. The machine begins to learn to correlate that every time it sees a dog picture, what makes this thing a dog? Because it has the answer, right? It knows that this is a dog. So it begins to make that assessment. Now, this is how you and I learned, right? When your parents taught you how to tell the difference between a dog and a cat, they did not describe like a dog has this height, a leg, or this color, or this length hair. They said this is a dog, this is a cat, and you learn to figure out what made it a dog and what made it a cat. After you'd seen enough dogs, you knew that this was a dog, right? uh, People didn't have to spell it out like what exactly made it a dog and what exactly made it a cat, right? So similarly, our computer algorithm does exactly the same thing. It learns to understand the important patterns that makes it a dog and the important patterns that make it a cat. And this is the idea of machine learning. So that's what machine learning is. It's a very specific set of techniques which are meant to achieve a specific goal where the algorithm learns to recognize a pattern and get an outcome. Okay, so that's machine learning. Now, what is data science? Anytime you use any data sets to make a hypothesis and conclude that hypothesis, you are using data science. So, for example, if somebody says, here are right now a lot of COVID patients are coming around, the world is very unhappy, lots of people are suffering, right? And everybody is interested to know when would the peak happen, like when would we reach the peak. Now, how would you find out what is the peak? So what will happen is people will collect a lot of data. They will see how many people are getting infected every day, what are the new cases, right? And they'll keep capturing how many cases happened in the 1st of May, the 2nd of May, the 3rd of May, 4th of May. And then they will form a small mathematical model and reach a conclusion that it seems like that right now the cases are flattening out or the cases are dropping. Now, there is no teaching. The model is, there is no, nobody's teaching a model how to learn the differences between a dog and a cat. They're using some interesting computational science, statistical science to to understand when a certain peak has happened or not. So every time when you use any data to make a conclusion, you're using data science. But when you're using it in a very specific way to teach an algorithm a certain pattern, then it's machine learning. And when you're using all of that in a very complicated way to try and make a machine conscious, you're making AI happen. Make sense?
Yeah, makes sense.
Okay. All different things. Today, a person can train themselves to become a data scientist. They can train themselves to become a machine learning engineer, or they can train themselves to become an AI researcher. When you want to be training yourself as a data scientist, you want to generally be very comfortable with statistics, probability, mathematical modeling. And anytime somebody gives you data, you try and use that as an evidence to try and understand what hypothesis is being evaluated and whether that hypothesis is true or not, right? Like the hypothesis in this case, in the case of COVID, would be, have we reached the peak? So the data scientist would take all that information and say no or yes, because they know how to take all that information about past cases to reach that answer. If you want to train yourself to be a machine learning engineer, you will train yourself in all the machine learning algorithms like support, support vector machines, or Bayesian trees, or decision trees, or random forest. These are all names of algorithms that you use to become a better at machine learning. And if you want to be like an AI researcher, then you have to obviously do a lot more to become a good AI researcher. Yeah.
Yeah. I think that's helpful for a lot of people who are looking forward to pursuing such a career path. My next question is, while researching a bit about AI, I came across something known as deep learning. I was wondering whether you could talk a bit about it.
So deep learning is the specific idea where you use neural networks to learn or teach a machine a certain idea. Right? The example of dogs and cats that I talked about is let's say that's the problem you want a machine to learn, or that's the use case that you want the machine to be able to figure out, then you have a couple of algorithms that you can use. One of those algorithms is called a neural network. A neural network is a special class of algorithm which has been built on the idea of a human brain. So, you've heard of our brain being made up of things called neurons, which are a specific type of a cell, right? A neuron has a certain thing called an axon and dendrites, right? So, but what simply happens is that all these neurons are like, connected to each other. When one neuron fires, it passes that information to the next neuron, and then the next neuron has a decision to make whether it'll fire or not fire, right? And in this manner, our brains, like a computational machine, where all these neurons are firing in a certain pattern, and as a result, we have these abilities to understand, perceive, think, and so on. So a neural network is an idea which is built on this idea of a brain. So you have small mathematical cells which are called neurons, and these mathematical cells have information coming in from other neurons. We do some mathematics at that cell, and that's almost like, uh, it decides to fire or not fire depending on what inputs it gets. And then today you have what are called deep neural networks. Deep neural networks mean that you have billions of neurons combined together in some really complex pattern, doing all this complex arithmetic to figure out a certain task. So, deep learning is the science of learning how to train neural networks to achieve a certain outcome, right? So that's what. So when people are interested in deep neural networks or deep learning, they should go and learn all about neural networks. And there are many kinds of neural networks. There are convolutional neural networks, recurrent neural networks, many other types of neural networks that we work with. So it's a whole area of science in itself. It's pretty big and somewhat complex. You need to do a little bit of arithmetic, but not all that complex. I mean, you don't have to know the innards so much, because nowadays libraries are available. You can just learn to code and use a neural network in no time. So that's the area of what is called deep learning. So everything that you see about, and self-driving cars. Have you heard of Elon Musk making self-driving cars? Right. So there is a
Yeah.
small neural network running. When you do a Google search, and Google automatically knows what is the next keyword you're looking for, because as you're typing, it fills it for you. There is a neural network behind running on the Google search bar. It is learning the specific thing that most people are searching about at some level, and it's able to anticipate what am I looking for at some level, right? When you're using Google Maps, in a very similar way, Google is making those assessments and trying to understand. When you go watch Netflix looks at all those movies that you've watched already, and then tries to make a guess what kind of a person you are, and so what kind of a movie you might like. There's a neural network running in the background making such decisions.
That's really interesting. Really, really interesting. Growing up, what are the few things that helped you foster your creativity and affinity for AI and machine learning and other such
Okay,
things?
that is a tough one. Shall I be honest?
Yeah.
Or okay. So I first of all did not know anything about AI when I was at school, right? We did not. We had. I had read some books. I don't know if you all have read or how much all of you nowadays read science fiction, but I had read a lot of science fiction. One of them was this book by Arthur C. Clarke called um, Space Odyssey, 2001: A Space Odyssey. There is a computer there called HAL, which is talking in that movie. And there is a whole idea of AI that Arthur C. Clarke talks about. Um, and so the only introduction to AI in my life when I was in school was these sort of science fiction stories, just like you all, right? So I had no idea that I would be ever doing AI. I ended up becoming an engineer. So because I got a good rank at the JE level, so my parents said, "Go, you should be reading, studying computer science." I didn't know. I did not know it in those days. I got into IIT in 1989. So those days, computer science was also not that known. It was coming up, but it wasn't like everybody owned a computer like nowadays, right? So it wasn't like that. So I ended up in computer science sort of by accident because I had a good rank. Not that because I knew that this is what I wanted to do, but I made good use of it. I tried to learn as much as I could, and then one thing led to another. Like I told you, when I started my career, I was not doing anything with AI. It was only when I came to India in 2007-8, when I started teaching here, that children were not interested in programming so much. Everybody was, I wanted to get them excited about programming. So I would think of cool ideas that would inspire them, excite them. So I started with games, like, that if I was to teach them games, maybe they would get interested in programming. So when I started researching about games, I started researching a lot about machine learning and so on, right? So it was only by accident that I got into this area of AI. But one of the more recent inspirations for me about AI has been that how AI can really make a strong can bring us strong improvement in our lives, if only we can use this technology properly, right? So remember the thing that I talked about when I joined forces with another friend, and we were trying to use machine learning, deep learning, to solve this problem of diabetic retinopathy. This was in 2015. We were looking at the images of the eye, the retina, and trying to identify if we could see damage in that eye, which could indicate diabetic retinopathy. And diabetic retinopathy is a very fatal disease. It can lead to blindness, and lots of people in third world countries suffer from it. So our goal was to be able to use AI. One of the problems that today people face in a country like India, is that they don't have enough ophthalmologists. So if you are a person in a village, it's not easy to go to an eye doctor because there is not many eye doctors in a village. And there have been many stories in India, about people getting blind, through, because of all these quacks that exist. So this is a real problem. So we were thinking that if we could make an AI agent, now we obviously can't have a doctor. We can't do anything about making a doctor available in every village. That's a very hard problem. But we could do is we could write an AI algorithm which could automatically detect if somebody has eye disease, and we could put it on a small device and give it to every village. That was possible, right? So that's the kind of an idea that I found very inspiring, that you can, by writing programs, really help society. And it still today is continues to be the strongest reason for me to stay in this field and keep working on it, is because I keep hoping that hopefully, if I can't directly myself make something like that, I can inspire a whole bunch of other people to think about how AI could improve our societies, our lives, in some very powerful ways. And that continues to be my motivation even today. So today at Nagarro, for example, or when we're working in AI, there's several interesting projects we do. We are working in several areas of disease diagnosis, healthcare. We are doing several things with medical images. We are doing several things with how factories get run, how decisions get made, how to make better decisions. All of these in the end help improve our world by a little bit. And then that's the general um, inspiration, affinity, whatever you may want to call it, for me to stay in this field and work in this field.
I think that was honestly really inspiring for not only me, but I think a lot of people or anyone who's watching this. I think everything that you just said is just going to push someone even more to pursue and just work even harder towards their goals.
Absolutely. I mean, AI has the potential to really change our world in ways that is very hard to imagine, but it's already happening. In the last 10 years, so much of AI has now come in without us knowing, everywhere that we might be. So if you're driving a car in Europe today, most likely there is a small AI running on it, which is helping you brake much better when you're closer to some place, because there is an algorithm which is detecting nearby objects. There is whenever you're on Google, you're basically being driven by AI at some level. Netflix is obviously a very crazy example where people are constantly, their behaviors are being assessed by an AI. And AI is now very, very ubiquitous, right? It's silently present everywhere. And in the coming 20 to 30 years, there will be no area in our lives which will not be touched by AI. Whether it is the lighting system in your house, whether it is your clothing, whether it's the electronic medical watch that you wear, which is counting your steps and the calories that you burn. Your computer is obviously going to be full of AI. My Mac is like AI ready at some level. It detects many things about what's going on, and my keyboard lights up. Like, for example, right now I'm in a meeting and my keyboard is all lit up with things like share screen end, and I don't have to do things on the screen. My keyboard can do it. So there's a very interesting AI happening here. Um, AI assistants are going to be all around. When you talk to people, sometimes you'll be talking to AI agents. You wouldn't even know that they are actually not people, right? And they would be helping you out in many forms, right? Now, AI agents, the interesting thing with AI agents is that they don't get tired. They don't need lunch breaks. They don't need to go out and, so you can wake up somebody at 3 o'clock and get medical advice or some help because those agents are active and available and so on, right? So my feeling is that in the coming years, especially as you all grow up, I mean, the important part of your lives is going to be, a lot of it is just going to be about AI in many forms, interacting with it, working with it, living and coexisting with it. And you all obviously have to figure out how to make it all happen, how to make it better for you, how to coexist better with you. But it's one of those technologies that you can be sure that along with biotechnology is going to totally dominate your lives in the next 20, 30 years.
And on some level, that does cause some sort of concern, right? Because since, like you said, AI is going to be present everywhere in our lives if it's not already. So regarding privacy or our information being sold to any third parties, do you think that's really something that us, especially people my age, should be worried
You should
about?
definitely be thinking about it, but not worried about it, in the sense that, well, worrying doesn't help in any form, right? These are new technologies, they are coming. You all need to be responsible. You all need to be aware of it, and you all will need to design a world where you can live safely with it, right? So, for example, when they invented cars, there was always this fear that people will get into accidents and people will die. Today, how many people die in car accidents? Huge numbers. But that did not stop us from building cars, right? Same thing with planes, right? When people built planes, there was always this fear that, hey, what would happen if these planes crash? And planes do crash and people still die, but most of them don't, right? And so we have figured out how to fly planes without crashing them, and fly planes without people, flying them into buildings and stuff like that, right? We are working things out, right? So same with AI, right? AI is a technology. You all have to figure it out how to use it in a careful, responsible manner. So I wouldn't say you all have to be worried. You shouldn't be. This has got more potential to help than to hurt. But then the problem of hurting is not in the technology; it is in the man or the human being when they use it wrongly. Like the knife really is not. Knife doesn't jump off the desk and kill me, right? It's only when a human being holds it to drive it into me that it hurts me, right? So it's always the human being who's the problem in my mind, right? So if you all design a world where human beings have certain limitations, certain ways that they can use AI or not use AI, it should be fine. It's another tool. One doesn't need to be afraid of the tool. One needs to understand how people should use it more responsibly, and then design the legal system, design the ethical system around it to make it all happen properly.
So, if you could tell us a bit about yourself with regards to what your and what the most exciting project for you has been so far that you worked on.
What's the most exciting AI project I've worked on?
Yeah.
Okay. Well, so now I lead a team of AI engineers. So every project we do is exciting at some level. It's solving a different type of a problem, right? So it's sort of hard to pick favorites when all those projects are important. But let me try and talk about a few of them. There's a very interesting project where we are looking at um, the microscopic image of what are called pathology images of human sperm, and counting sperms which are moving using machine vision. This is very exciting and interesting. It is one of those topics which seems very cutting edge, because so far all the techniques of doing this used to be chemical in nature or electrical in nature, and now you're using perception meaning vision, to be able to do something like this with very high accuracy. So it's a very exciting project. I am very thrilled about that project at some level. There's another project that we are doing where we are teaching a machine to make very good decisions. So, what are we trying to do is that this machine, this agent, is sitting in an inventory. This agent is trying to control the inventory in such a manner that they need to make decisions how much to buy and when to buy in such a manner that the inventory never runs out of stuff, right? At the same time, you don't want to overstock your inventory, because if you overstock your inventory, you have to buy a lot of stuff. So, how do you become a very good decision maker when you have to run inventories, right? So, we are teaching an AI agent, just like, I don't know if you all heard of, if you've heard of AlphaGo. Have you heard of AlphaGo?
I haven't heard of it.
Okay. So some time ago, some people in OpenAI, a company called OpenAI, and other, Google Brain and many other companies have been working on these topics where they're teaching algorithms or agents how to play games. And these agents become so good at it that they can defeat human players very, very easily, right? So what you do is that you let the machine learn from the environment. So it's a very powerful new approach to solving machine learning. It's called reinforcement learning. So we are using the same kind of technologies to be able to do that. That's very, very exciting. Um, we are teaching how to use cars, collect information. Cars, as they are traveling on roads, like imagine there are all these cars traveling in Delhi. What if every car was using its camera to capture the condition of the roads in the city and uploading that information to a central place? So without doing anything, you can get the state of roads of Delhi without any effort, really, right? So we are working on something like that, where we are collecting information using cars as a data collection input, and collecting weather information, road condition information, crowd density information, and then using AI, we are making very interesting decisions and intelligent decisions around it that helps people like law enforcement agencies, road transport, safety, to make better decisions around what they should be doing and not doing. All these are very exciting projects in my mind. So many such projects, yeah.
Thank you for sharing them with us. I think regarding the project about the sperm, that that's somewhat of a breakthrough, right? In terms of how research is done.
It is. It is. It is one of those R&D kind of topics where people are trying to push the envelope in some very interesting ways. It's actually, see, with most AI, the important idea is cost, right? So AI is interesting because it decreases the cost, the amount of effort or cost it takes for you to do something, right? Now, if let's say you are spending $10 to achieve a task, like, I don't know, count something, but now you can do the same thing for $2, then you have significantly reduced the price of, or the cost of how much you incur when you achieve a task. And this is a breakthrough, right? So technology is a breakthrough if it helps the economics become better. So the goal with AI is to really do something with the same quality that somebody else was doing or some other technology was doing, but at much lower cost. Right now, cameras are very cheap. Cameras are not very expensive. I mean, you have a camera on every phone, right? Everybody in this world who has a phone, a smartphone, has a camera, right? So cameras are not that expensive. Now, imagine if you had a technology which could use a camera very, very powerfully, suddenly it will be available to so many people, right? So suddenly you have a means to uh, bring a certain outcome at much lower cost than it would have been otherwise. Otherwise, you might have had to get everybody to buy a camera before you could do something, right? Now suddenly everybody can use their cameras and get an outcome. So these are very powerful things, and you're absolutely right. The sperm counting project is very, very breakthrough project in that form. Yeah.
For my last question of today, I wanted to ask you what you would like to tell to someone who is currently, as of now, interested in the sphere of AI or anything related.
Okay. So first of all, I'd say that this is a very good field to get into. So you've obviously, if this is an area of interest, um, you have made a very good, it's a very rewarding career in general. So that's the first thing I would say. The second thing I would say is that AI is a very big field, so it's important to decide what aspect of AI do you think you have strength for. See, we have all kinds of interests, and a lot of times we get into an area because of the hype that AI, I want to do something really cool, and AI is the coolest thing, so I want to do AI. But maybe that's not the right way to think of it. The right way to think of it is, for example, if you like mathematics, if you like a little bit of programming, then maybe computer science is a good area to get into. And the first thing is that you have to be a good computer scientist to some extent to be able to do AI in my mind, because it's a lot of computation. So I would say think about computer science as the topic to get into, as an area to get into. And computer science is also many things. There are many things that are happening there, but two things you got to be really good at. One is you should really enjoy programming. So I tell people that not to worry about what you would do in the end. Try and enjoy the act of programming. Try to enjoy the creative aspect of programming. Programming is very creative. You can create anything on your computer, and you don't need anything extra, right? So if you become good at it, then topics like AI will automatically become very simple for you. But if you try and approach that, no, no, I want to do something complex very quickly, then that's not the best way to do something. The best way is to really build your foundation slowly and over a period of time. So there's a long time ahead as students. If I think of somebody your age, I would say focus on programming, focus on enjoying maths, and focus on enjoying it, not just doing it, right? Focus on try and see how you can enjoy maths, how you can enjoy programming. And then in due time, you would find yourself very naturally. Anybody who starts to go in the area of programming today, in 5 years they are going to encounter AI. It is not. It's a certainty almost. Like they will encounter it, right? So it's not like you have to do it today, but if you do the basics right, then it will become very simple 5 years later. So that's my suggestion to that person of your age, right? Enjoy programming, enjoy maths, enjoy reading about stuff like this. Read a little bit more science fiction. Look at how people like Arthur C. Clarke and G. Wells and many others have imagined AI. Isaac Asimov has written a very beautiful science series called The Foundation. It's going to come on Apple TV, I think, soon. I saw a trailer of it. I was very excited. I was like, okay, I'm going to write to you all and tell you about this science fiction thing you should all watch, because in very silent ways, it'll teach you some very interesting things and make you all very open to the ideas of science and computation science and so on. So yeah, those are my thoughts, right? Focus on the basics, become good at programming, and not good in the sense of good, but enjoy programming, enjoy that. Those are the keywords. AI will happen automatically.
Thank you so much for taking out the time, Mr. Anurag, and answering all my questions. And if anyone who's watching has any further questions, feel free to email us at the email address given here, and Mr. Anurag will happily answer them for you.
Okay. It was a pleasure talking with you. You asked really good questions, and more importantly, I hope all this talking that we did is useful to people. So good, very nice. Thank you so much for having me on this interview.